Hey guys, welcome back to Bit Byte Kilobyte. We are at chapter 5 and we'll be talking about arrays and collections in today's video. We already spoke about loops in the last video. We are going to use a lot of those loops in today's video. So if you have not watched that video and you need to learn about those, please go ahead and watch that first. So normally whatever variable we have used so far, we have just created a single instance of a variable and we have stored certain value to it. But arrays or collections comes into picture when you are trying to store a set of values, right? So if you're storing one particular student's name, you can store it in a string type variable. On the other hand, if you want to store a whole class of student names, then you will need a collection. You need a set. To store that, we use a collection or an array. Let's understand that a little bit more with an example and how we can access individual elements of the array. So if you see this, a simple example here, John stays in a small house. The name of the house is small house. Address is Happy Street, Planet Earth, right? So John stays alone in this house. It's a single house. So you can describe John in this fashion. Similar to this is a single standalone variable. Here we have integer a and we are storing 10 to it. So a gets a memory location and then 10 gets stored in that memory location. All happy, single. Now when we talk about a big apartment where there are a lot of houses in there, so you cannot have a variable for each and every house, right? So what we do here is John and two of his friends are now living in this apartment. So John's address, Mark's address, and Mary's address are common in a way because they all live in this big house, Happy Street, Planet Earth, right? But within this apartment, to get to John's apartment, you need a identifier. So identifier for John's apartment is apartment 1, same of Mark is apartment 2, and same of Mary's is apartment 3. So in the same way, when you declare an array or you try to store a set of variables into a collection or an array, this is how you declare that. Instead of declaring it as int b, you make int square brackets and then b, which makes b of type of integer type array. Okay, and now you need to instantiate that array. So this is how the array is instantiated. Here the 3 in between the braces, whatever you're seeing, this means that the size of the array is 3. Now arrays are fixed in size. Whatever size you define in this array is what the size of the array is going to be. You cannot store more than 3 elements into this array. So now how do you access these individual elements? You access those using indexes of these elements. Remember, the indexes start from index 0 and not from 1. Even though in real world we start from 1, in C# or in most of the programming languages, indexes always start with the number 0. So we have 0, 1 and 2, which identifies 3 of these blocks, whereas b as a variable points to this array. If you access b, you access like this. If you want to go inside this and get into individual elements or store them, you will have to access them using these indexes, which are very similar to how you are accessing individual apartments within a bigger apartment. Make sense? Now let's go back to C# and see how arrays are used. So here we have created a small program, collections, where I will be demoing different types of collections and how we are going to use them. Okay, so we start with array and then we move on to more advanced collections. Now a basic array is declared like this, like we saw in the presentation there. This defines an array of size 3, as we said, and I store 3 values here. Now you can access these elements in the array using a for loop. So what you can do is you can instantiate an index with value as 0. You can iterate up until 2, 0, 1, 2, as I said, is the maximum element or the maximum index, and then you increment it at every loop. So now let's run this program and see how the output turns out to be. Okay, so we are at this line. I will continue. So I will continue here. I set these 3 variables and I start iterating. You can parallelly see in this window what is happening here. So second time it prints 20 and the third time it prints 30. So all these elements are now accessed, I will go out of this loop. Okay. So I've put a semicolon here just so that I can put a breakpoint. If I don't have a semicolon, I cannot put a breakpoint on an empty line. So semicolon does nothing other than just being a statement, an empty statement. Okay. So now here we are at the breakpoint. This is how a basic array is accessed. You can access individual elements, store and read them using these indexes. So this is one way of creating an array and initializing it. Now there's another way to do that, a more shortcut way. So what you can do here is you can create an integer type array here and store 1, 2, 3 at the time of declaration itself. So this is a valid statement. So you don't need to have 3 different statements here. You can directly declare and initialize the array at the same time. Okay. Remember, in this situation, you don't need to put the new int and the size of the array. C# will automatically understand from the number of elements you are trying to initialize this with. Okay. Like you can create integer type arrays, you can also create arrays which are of any data type or any class types, right? So here I'm creating an array of type string, string type array, and I'm storing John, Mary, and Mark onto this array, right? Similarly, again, I'm iterating through this array and printing the content of this array. Now let me run this program and see how is the output. So if you see here, it actually printed John, Mary, and Mark. Now arrays can be multidimensional as well. You can have a single dimensional array like we just saw, or you can have an array with multiple dimensions. So here's an example of a 2-dimensional array, which is a 3x3 array. So here you will have 9 elements. So you can access the first element with 0, 0, then 0, 1, 0, 2, that's the first row, and then you move to the second dimension. So here you have 1 dimension, here you have the second dimension. Technically, you can go to any number of dimensions, but beyond 2 dimension, it becomes very hard to show it in a 2-dimensional screen. You will have to like think it in your imagination how that array will be stored in memory. To be honest, in my 12 years of career, I've never used more than 2-dimensional arrays. Okay, that too, even 2-dimensional arrays I've used very rarely. So let's move on to C# and see how this array is created and accessed. So this snippet actually creates in C# a 2-dimensional array of size 2x2. That means there will be 4 elements. We declared it using this statement. We don't use 2 brackets like we would have used in C language. We instead do it with a comma in between, right? So this indicates that it's a 2-dimensional array, and these are the 2 dimensions, length of each dimension. So this is how you access the elements. Now to print data from a 2-dimensional array, what you will have to do here is you cannot have a single loop. You will need a nested loop to print all the elements of a 2-dimensional array, right? So here 2x2, this loop will run 4 times and print all these 4. So what it is doing is the outer loop is running from I is equal to 0 to 2, and the inner loop is doing 0 to 2, and I'm printing I comma j. Effectively, it will print all the elements of this array. So let's see the output here. So it printed 20, 30, 40, and 50 along with their indexes. One thing I just wanted to point out, in this tutorial, I'm using this kind of way to print a string. This is a very handy way to actually format string. This is called a formatted string, where we are giving these placeholders inside curly braces, 0, 1, 2, and so on. You can give n number of placeholders. Now 0 gets replaced with what you put outside the comma here. So in this case, 0 gets replaced with I, 1 gets replaced with j, and 2 gets replaced with the content of this array at location I comma j. Okay, so this is a very handy way. This is something that I'm using new in this chapter, so wanted to point that out. So now let's move on to collections. So there are many collection types in C#, but the main ones that we use day to day are these 4. So one is list, that is the most used one. Then we have stack, queue, and dictionary. Dictionary is also very frequently used collection that we use at work. Okay. Now let's start with list first. So what list is, it's basically very similar to an array, but The difference here is list is a type which is provided to you by C#. In addition to like what array does, it gives you a lot more flexibility and lot many functions to access these elements and manipulate these elements. So let's see how. So you declared a list like this. You have a list, and you here within these angular braces, you actually provide the data type of the type of data that this list will hold. This is also called generics, where this list object is created without a hard-coded type inside it, and you actually pass the type here, which makes the list which can hold data of this type. Okay, so here we are creating that list. In array, we added elements using their indexes. Here, what we are doing is we just add elements using the add method. As you see here, I'm not mentioning the size of that list. So the list can grow infinitely, right? So there is no hard-coded capping on the size of the list. So you can keep adding elements as long as you want. Now, we move ahead. We added 2 of these values, and then first method that our first property of list that we want to cover is count. At any point of time, my list dot count would give you number of elements that are present in the list. So here I'm storing it in a variable called len, and I'm trying to print that element. Okay, so let me put a breakpoint here and run it till here. So as you can see, total items in list is 2 because those are the 2 elements we added. What you can also do is you can also access the list using normal indexes that we use to access arrays. So you can put within square brackets the index, which again starts from 0, and access that particular element. So if I'm trying to access the element at the 0th point or the 0th index, that is this particular element. Let me see if we print it. What does it print? So it does print first element, nothing. So why is that? So it did not print anything. Let us see why. This is because we missed this here. Okay. So now let me go back to the statement, set as next statement, and re-execute the statement. Okay. Now let's see whether it printed. It did print. Okay. So first item is hello. So now moving forward, what I'm trying to do is I'm trying to print all the elements in the list like we did for array. What you can do is you can start from index 0, go till index.count, 1 lesser than that because it starts with 0. And then we are printing that at index 0, what element is there. So now let's run this till here and see the output. So as you can see, it printed both hello and world, the 2 elements using indexes. Now we move on. In the last chapter, while covering loops, I told that I will cover for each when we learn collection. So this is where we learn for each. For each is another type of loop that works with collections. So here my list is my collection. Instead of writing a complicated for statement like this, what you can do is you can declare a variable s, which is of string type, saying that string type s in my list. So you should read it like this: for each string s in my list, right? So my list is a collection. What we are trying to do is for each string in my list collection, do this, and do this here is print that value of that string. Okay, so I will put a breakpoint here and run this and see the output. So it printed hello world. So that's an easy way to access any collection using a for each loop. So far we dealt with inbuilt data types like integer, string, etc. You can also store within arrays or within any collection your custom data types, right? Or the classes that you have made. So here I have a class called student, which has 2 properties in it, name and age. I've declared already the class here, and it has a function called print details, which actually prints the name and age in a fancy format. Okay. So now I will create 5 different students with their name and age different and store it into this collection. That is how I'm doing it. Now what I'm doing is for each student, I'm printing the details. So if I run this program, you will see it actually prints all the student details here. Okay, now that we have the student details stored into the student collection or student list, you can hover on top of it and you can see the count. You can also click on this small arrow here or small triangle and you can see individual elements within it. You can further go inside this and you can see the value of each individual elements or the properties of each individual element. Okay, very handy. So now, so far we have 5 elements in it. There is a method again for list which says remove at. So there's another handy method where you can pass an index and it will remove this element at that index. So the first element here is John. Let's try to remove element at index 0. I remove it. Now let's see, there are 4 elements now and the first one is now Mary. Remember, first one is not empty. Everything shifts now because you have 4 elements, right? So this is unlike arrays. In array, if you clear out something, that space doesn't go away. Okay, you can make it null, but that space will stay. Array is a fixed size structure. Okay, here it is dynamic in size. The size changed when we removed something. Okay, now if we try to print this, we know what it will print. So I will put a breakpoint here, run this, and it will print 4 because 4 is the number of elements now. You can do a very handy search operation on list as well. So how you search is using a predicate. So how you search in list is you put the list name and you use a method called find, which is a method of list. Here what you do is you define a predicate. You say you're trying to find an element S where s.name equal to John. This is how we define it. We put s, then equal to greater than sign, and then s.name, the condition here, which is s.name equal to John. So here, since we have already removed John from the collection in this step, it will not return me anything, and found will have the value null even after executing this. Okay, so let me go ahead and execute this. So as you can see, found is still null. Okay, now what I'm trying to do is in the same found variable, I'm trying to get a student whose name is Mary. Okay, now Mary is present in the list. So if I execute this, found will now have reference to Mary. Now name is Mary, age is 30. That's what we had set here, right? So that's how you can find particular elements. Remember, this is by reference again, like we spoke in our earlier chapters. Any change in this variable, if you make here, it will actually change the variable which is there in the collection also. Okay, let's quickly try that out. Here, if I make age of Mary 31, okay, we change that reference, which is pointing to the actual object in memory. Now, if we go back to students and check element 1, which is Mary, the value has changed to 31 here, right? So it is basically returning you a reference and not a copy of that object when you are trying to find something. Be careful with that. Now let's move on. Here you can also do kind of more than one record search. Here what I'm doing is instead of find, I'm saying find all elements s where s.age is greater than 10. This sounds pretty similar to how we write our SQL statements in database, right? So we are finding a s where s.age is greater than 10. So what it will do is it will give you a list of students where the age of the student is greater than 10. Okay, so here in our case, if we go and check our output here, John is already gone now, right? So we have Mary, Terry, Hank, and Gerard. Here we will get Mary, Hank, and Gerard, and Terry will be dropped because Terry is 5 years old. So let's execute this and print the result as well. Now let's go ahead and run this. And as you can see, search result, it gave Mary, Hank, and Gerard. It dropped Terry because Terry is 5 years old. Okay. Now, what you can do also is you can remove items from the list using remove all method. So remove all again takes a predicate. Here what I'm saying is remove any elements where age is greater than 40. So here only Gerard is in the list whose age is greater than 40. So we will remove this from the collection or list. If I run this, it will tell you how many elements were removed. Okay, here one element was removed, which was Gerard. Now if we go to the collection student, here you can see there are 3 elements now and Gerard is gone. The last one is Hank. Okay, good. So now let me go ahead and print this too. It's just a confirmation. It actually removed 1. Okay, so that was few of the very common methods or usage of list. List is very extensively used in our industry. So I would say go through some other methods that list supports. For most of the methods, if you just hover on top of it, it will tell you what the method does. And of course, you can check more in Microsoft's official site, where they will give you details of each and every method and how to use them. Okay. Let me know if you have any doubt with any of the methods. I'll be happy to help you there. Now let's take a quick break and resume with the remaining collections in the next video.